right, good evening, folks. I see we've got people filling in for tonight's presentation, which I think is going to be a fantastic one. So I'm glad to see we've got some audience already joining us. We're going to start the presentation at about 5 minutes past 7 to make sure everyone has time to log in and get Zoom started. So feel free to take a moment to grab a snack, grab a beverage, grab anyone else in your household and bring them in to see the presentation tonight. Like I said, we'll get started at about 7:05. And for those of you fortunate enough to sign in early, you might get to hear this once or twice, but there will be a Q&A box that you can type any questions in throughout the course of the presentation this evening. Our plan is to take those questions at the end of the program, so you can feel free to submit those at any time during tonight's presentation. I hope everyone out there is doing well and feeling well, and if you are one of those folks who enjoy the cold weather, I'm very happy for you. If you're like me and you prefer sunnier weather, well, we can all commiserate together. Raj, do you prefer the summer or the winter or in between?
I prefer the in-between.
Yeah?
But it hasn't been that bad this winter just yet, so.
Not quite yet. The first snow is under our belt, so it's good to get that out of the way.
Mm-hmm.
I like springtime the best. That's my favorite season because I'm a big bird nerd. I love watching the migratory birds come back, and so I look forward to that every year. I see some familiar names in the chat here. Hi there, Megan. Thanks for joining us tonight. And again, for those of us joining in now, we'll be starting the presentation at about 7:05 to give everyone an opportunity to sign on and get comfortable and situated for the program. My name is Brad Peroni. I am a program developer at Carnegie Science Center. And tonight we are joined by Raj Krishnaswamy. And we've already got some questions popping up in the Q&A box. That's fantastic. If you haven't noticed that Q&A box, I believe it'll be at the bottom of your Zoom window. You can type in any questions that you have at any point during the presentation, and we will address those questions at the end of the program. The chat, if you're used to Zoom, the chat should be turned off. If you try to use the chat, don't be disappointed. Your computer's still working just fine. We just disabled that so that all those questions come in through the Q&A. We've had other instances where they came in through the chat and we missed a few. So we want to make sure we see all of those questions come in.
So I really like that question that showed up in the Q&A box.
I can't see it yet because I have my screen sharing set to maximum. So I look forward to seeing it. So for those of you who are joining us for the first time, welcome to Café Sci. We are so glad that you're here this evening with us. Café Sci is our monthly lecture series where we invite scientists and STEM professionals of all stripes to share their work, their experiences, their stories with us and our audiences at Carnegie Science Center. This is geared toward adults, but if you've got some science-minded and technology-minded youngsters at home, Raj has assured me that this is all going to be totally above board tonight, and they're welcome to watch too. So feel free to bring anyone around to check out the presentation this evening. We've still got people filtering into the room. I'll give it just another moment, and then we will get started. For those of you who are in here already, feel free to text a friend, send a Facebook message, post on Instagram that Café Sci is happening right now, and that way all of your friends can see tonight's presentation also. All right, so we're going to get started. My name is Brad Peroni. Welcome again to those of you who have been here since we started the broadcast, and to those of you who just logged in. I am a program developer at Carnegie Science Center, and it is my pleasure and privilege to be hosting these online editions of Café Sci. Café Sci is our regular monthly lecture series, and we have a fantastic guest this evening. We have Raj Krishnaswamy, Global Director of Material Science Innovation at Braskem, and we'll stop that screen sharing for just a moment. Raj, can you still see my screen sharing, or did that disappear?
No, I can see it.
Oh, okay, great. It disappeared on my screen, so.
Okay.
I'm used to having a much bigger monitor when I'm working on site. All right, so welcome to Raj. Raj Krishnaswamy is currently the Global Director of Material Science Innovation at Braskem. Prior to his tenure at Braskem, Raj spent 8 years at Metabolics Incorporated and 9 years at Chevron Phillips Chemical Company in various R&D and leadership roles. He's a fellow of the Society of Plastics Engineers and has received the Research and Technology Lifetime Achievement and the Husky Education Awards from the Society of Plastics Engineers. He's an alumnus of the National Academy of Engineering Frontiers Symposium and has received the Outstanding Young Scientist Award from Chevron Phillips and multiple Board of Directors Innovation Excellence Awards at Metabolics. Raj has co-authored about 40 peer-reviewed journal articles and is a co-inventor on over 40 patents and applications. So we're going to pass the microphone over to Raj right after I thank our sponsors. Café Sci is presented by PPG and sponsored by Cook Myosite, and you can register for all upcoming Café Sci presentations at carnegiesciencecenter.org/cafesci. That said, Raj, the floor is yours. Take it away, sir.
Thank you very much, Brad, for the introduction. I hope you can hear me okay. So Brad, if you could confirm, are you able to see my screen?
I see your screen and hear you loud and clear.
Perfect. So thank you again for the introduction, Brad, and I'm really happy to be here. Have a fun. I certainly have enjoyed the Carnegie Science Center. We've sponsored as a company, Braskem has sponsored various activities at the Carnegie Center, the Science Center, and also the Carnegie Foundation. So really happy to be representing Braskem today to talk about innovation. And really what I'm going to be doing over the next 30, 35 minutes is sharing some perspectives on innovation. I'm going to try to focus the conversation or focus the innovation perspectives around the chemicals industry, but I've tried to keep it generic so that we don't get into the details of the chemicals or the materials industry specifics. So before I get into the meat of the presentation, I thought I should spend a minute or so sharing some views about 2020, right? 2020 has been a challenging year. Most of us have spent a lot of time working from home, working and studying from home. And so we've had to adapt to this new environment. We've had to adapt to uh, this new setting, this new place where we're carrying out our work functions or studying, preparing for school and so forth. So I thought I'd start off by sharing a glimpse into our household about some of the ways that we have coped with this new world, right? So here you're seeing pictures of my kids studying really hard for their tests and exams. Uh, just thought I'd start off here. So before I go into the meat of the presentation, I want to set the stage and talk a little bit about the chemicals industry. So the chemicals industry in the United States, it's worth about $600 billion. So that's about 25% of the US GDP. And the United States globally is the second largest producer of chemicals, basic chemicals. China is number one. And so 600 billion out of a 4 trillion market global, of a 4 trillion global market is really significant. And the chemicals industry accounts for about 600,000 direct jobs in the US. This is also an industry that has experienced pretty good growth over the last several decades. Over the last decade or so, you see that the chemicals industry is generally on average beating or the growth rate has been slightly above GDP, US GDP growth. Of course, the growth rate of the chemical industry in general was much higher in the 90s and 80s, but that growth has started to slow down, but still keeping pace with GDP. From a research and development perspective, if you go back to 1980s, early 1980s, companies typically invested about 5% of sales into research and development. That number has steadily declined to where it's about 2% of sales today. That, when you first look at that, that sounds alarming from a research and development point of view, but it really is not. Because this industry has grown tremendously over the last several decades. So the absolute value of the total industry is significantly higher today, many-fold today compared to where this industry was, let's say, in the late 1980s or early 1990s. So in terms of absolute dollar amount, the R&D expenditure is substantial today. Secondly, there's been a lot of consolidation in the industry. So with consolidation, you gain a lot of synergies. And so with these synergies, you're starting to see a slight decline in R&D investments. And lastly, technology advances, right? In the 1980s, computers were not widely available. So today with computation capabilities, with mathematical modeling capabilities, and automation, robotics, you don't need to invest as much to achieve the same, or for a given dollar, you're able to accomplish a lot more in R&D. So this is still a substantial number, but the average spend in R&D for chemicals industry is lower compared to some of the other industries, let's say like pharmaceuticals and so forth, right? But still 2% is a significant number. The next point, I'm going to elaborate on this a little bit more in the next slide, but you've also seen the R&D emphasis shift from developing or trying to create new chemistries and new molecules to focusing on new products. And these new products can be a combination of previously existing chemistries and molecules. So when you think about the impact that R&D has made to the bottom line of a business, you'll note that typically in the chemical industry, the sales that come from new products, and these are new products that are a consequence of R&D investments, average between 6 and 20%, depending on the industry and depending on the specific subsegment within chemicals. So again, when you think about a number of 10 to 15% of revenues coming from R&D investments, that's still significant. So we've looked at the general trend in the chemical industry. We've looked at different metrics. One, we've carried out a decade by decade analysis of the patents that have been granted in the chemicals field. We've also looked at new products and new businesses that have emerged in the chemical industry. And you see a general shift as you go from 1970s to today. Early on in the 1970s, 1980s, there was a lot of emphasis, like I said, on new chemistries or new molecules. So companies were trying to discover new molecules to bring to the market. That emphasis started to shift towards catalysis. So again, trying to invest in new catalyst chemistries to make the same products, but make them much more efficiently, or make products with very specific targeted properties. So that's where, along with catalysis, came advances in manufacturing sciences, process engineering, process intensification. That then led to new products being introduced. And within the polymer industry, new products oftentimes were blends of existing polymers or existing materials. So again, you see there was the shift from new chemistries to now new products. But over the last 10, I'd say 15 years or so, the field of industrial biotechnology has emerged. What does that mean? So typically the chemical industry tends to rely on fossil fuel for feedstock. The chemical industry, the products that come out of a chemical plant depend on fossil fuel. That has started to shift a little bit, right? So with the emergence of industrial biotechnology, where we can now use bio-based carbon or plant-based carbon to make the same chemicals that you were once producing using petroleum-based or fossil-based feedstock. So with that, I'm going to address the first question that was posed in the Q&A box. The question was about Braskem being a green company and yet being in the petrochemical or operating in the petrochemical industry. We refer to ourselves as a green company. Why is that? So the first point I'll make is Braskem is a petrochemical company. Braskem is a global petrochemical company. But Braskem is also the world's largest producer of bio-based polyethylene. So polyethylene is a commodity polymer. It is the largest volume polymer of plastic that's produced globally. And almost all of it is produced using fossil-based carbon. Braskem produces polyethylene using fossil-based carbon, but Braskem also produces polyethylene using sugarcane as the feedstock. So we take sugar, ferment the sugar to ethanol. The ethanol is dehydrated to ethylene, and then we produce polyethylene. So we produce and sell polyethylene that's based on fossil carbon, and we also sell polyethylene that's based on bio-based carbon. We produce over 100 million pounds annually of bio-based polyethylene, bio-based copolymers of ethylene and vinyl acetate. So ethylene, vinyl acetate polymers are used in shoe soles. Polyethylene is used in everything from bulletproof vests to gas pipes to trash bags to food packaging, right? So we do produce a fair amount of materials using bio-based carbon, and that's why we refer to ourselves as green. The second point I'd make is we're looking to expand the space. We've actually built a pilot plant today, and we're operating a pilot plant to make ethylene glycol that goes into PET. PET is used to make fabric and soda bottles, for instance. So we're now making a critical ingredient on a pilot scale, a critical ingredient, again, using bio-based carbon. So these are the two initiatives that I can share, but we're also looking at a whole slew of other initiatives that would tap into various aspects of industrial biotechnology. So industrial biotechnology has started to emerge. And I believe that this is going to gain traction over the coming years. So if you think about fossil-based carbon today, if you think about some of the trends that are ongoing in the world today, one of those trends being electrification of cars. So particularly in growing economies like China, the number of electric vehicles sold today is very comparable to the number of internal combustion automobiles sold today. And the growth rates of the EV cars is much higher. And this trend is catching on globally as well. So if we could reach a tipping point if globally about 20 to 30% of the cars, 20 to 30% of the automobiles are no longer requiring refined gasoline. So if we reach that point, refineries will start to shut down. And if refineries start to shut down, then the chemical industries will lose a big source of their feedstock. So petrochemical companies have to look at alternate sources for feedstock. And that's where I think industrial biotechnology becomes relevant. And it is going to increase in relevance in the coming decade, perhaps coming years. And lastly, I'm going to come back to this later on. The growth in the chemicals industry or the growth in the plastics industry over the last 30, 40, 50 years has been tremendous. Billions, hundreds of billions of polymers, hundreds of billions of pounds of polymers are produced globally. A lot of the disposable plastics end up in our environment. They end up in our waterways. They end up in the oceans. That's not good. And so circular economy is starting to become really significant even within the petrochemical industry. We're all responsible to ensure that waste plastics don't end up in our waterways. Waste plastics don't end up in our environment. So we need to find creative ways to reuse these plastics. Either reuse them in new applications or create or convert these plastics into their fundamental ingredients so that they can be polymerized subsequently. So circular economy is becoming really important. So here's a quick outline of what I am going to be sharing with you today. I'm going to start off by talking about disruption. What does disruption mean to industry? And why should people in innovation care about disruption? We'll then spend a little bit of time talking about one way to classify innovation, and then talk about strategy. How do you develop, what are the elements of an innovation strategy, and how does one go about developing a strategy, again, within a corporate setting? We'll then talk about different sources of inspiration for innovation. So when I say innovation at intersections, I'm really referring to innovation that happens when two or three different disciplines come and choose to work together. We'll talk about open innovation. What does that mean? And lastly, look at innovation by end user. So these are just three sources of inspiration I've chosen for new ways to innovate, particularly in a more dynamic world that we're living in today. And finally, provide some closing remarks and talk about some of the disruptive trends that are upon us today. So again, not knowing the age group of the audience, I hope at least some of you in the audience know this company, Kodak, right? Maybe even 15, 20 years ago, the most common means of taking pictures was you took pictures using cameras that had photographic film in them. And then you would take the film out, take it to a company, or take it to a Walmart, or take it to a pharmacy and have the film processed into pictures, processed and printed into pictures. Kodak was the leading company in the photographic film market. At the peak, they had 35 to 40% of the global market. Kodak was the most admired, or one of the most admired companies globally. They were admired for their creativity. They were admired for their innovation because they made really good products. In today's world, we talk a lot about agility, right? And agility is really a new mechanism to increase the speed of innovation. And Kodak championed agility when they transitioned from black and white film to color film. The initial versions of that product were very poor in quality compared to the black and white films, but they didn't wait to perfect the product. They took it to the market and perfected on the go. So here was Kodak, had the largest market share in the space. They were the most admired company. They were known for innovation. And suddenly, overnight, they're out of business. Why? It was the emergence of the digital cameras, right? So Kodak was so focused as a business on their core product, which is the photographic film, that they forgot to pay attention to this emerging disruption, which was digital cameras, where now people didn't have the need to use and process film. And so Kodak had to declare, they were forced to declare bankruptcy in 2012 because they did not see the emergence of the digital era, the digital camera space. But interestingly, the original invention of the digital camera actually happened at Kodak. The original patent for the digital camera was granted to Kodak in 1975. So even though as a company, they invented the digital camera, they chose not to focus on that concept. And so they had to go into bankruptcy. Again, interestingly, one of the means that Kodak used to get out of bankruptcy is they took the patents assigned to Kodak, the patents that pertain to digital cameras. They sold the rights to those patents. They sold those patents to Apple and used the proceedings to get out of bankruptcy. So an example where a really phenomenal company became irrelevant almost overnight because they were blindsided by disruption. I want to share another example. Before 2005, 2004, many of us that went on road trips, either on vacation or when we went on business trips, we would actually print out line by line directions to go from point A to point B. Or we would have these maps, AAA maps, sitting next to the driver's seat as we were going. So there was this great invention, GPS devices, right? You had TomTom and you had the Garmin. They revolutionized travel all over the world, right? At one point for a few years, these GPS devices were the most popular Christmas gifts. Very popular. These companies were doing really well. They were actually investing a lot of money back into R&D, but all of the R&D dollars were focused on improving their existing product. And when smartphones hit the market in 2009, 2010, the market for these GPS devices vanished because now you have smartphones. I can take pictures with these phones. I can also get directions using these phones. And so these companies, TomTom, Garmin, they became insignificant with the emergence of the smartphones. Again, I just wanted to share two examples of disruptive trends that can take out entire industries, that can really minimize your business. They can minimize even industry. So one has to be mindful of disruption as you start contemplating about innovation and innovation strategy within any organization. So I want to come back, we've talked about disruption and want to come back to one disruption that we're facing as a chemicals industry or as a plastics industry today. And that has to do, and we discussed this very briefly just a couple minutes ago, really around circular economy. So this is the disruption that's upon us, that's upon the petrochemical industry today, particularly the materials, the plastics industry. And again, going back to the one question that was posed early on, want to make a couple of comments about what we're doing as Braskem to tackle this problem. Right, we've made commitments that we're going to be a carbon neutral company by 2050, and it's a long path to get there. It's a challenging task for a petrochemical company to get there, and we're going to get there through a variety of means. We're going to look at enhancing the energy efficiency of our operations. We've already started to source renewable energy for many of our operations. We're also going to look at ways to capture carbon. We're going to look at using the captured carbon, like carbon dioxide emissions, and converting them into useful products. We're also going to look at circular economy by investing in biodegradable polymers. So we're trying to come at this through a variety of mechanisms, and not just Braskem, but others in our industry. They are also looking at circular economy because, again, circular economy will very soon become our license to operate, our license to stay in this business. So when we think about disruption, right, there are many industry experts that don't really see disruption coming, right? So you have to be really, really deliberate when you think about these disruptive influences. I'm going to just mention one quote. This is from Steve Ballmer, who for many years was the CEO of Microsoft. Steve Ballmer is still a very successful business person and known for his strategic mindset. But in 2007, he said, there is no chance that the iPhone is going to get any significant market share. That was what the CEO of Microsoft said in 2007, right? Okay, so we're going to shift gears and talk about innovation now. So there are many different ways that one can classify innovation. So within a corporation, you have a portfolio of innovation projects. Let's say you have 10 projects, or maybe you have 100 projects in the portfolio. You can classify these innovation projects using many different lenses, and I'm just going to present one of those lenses here in this slide. You can take projects and classify them as either linear innovation, non-linear innovation, or disruptive innovation. Linear innovation, they're really focused on incremental changes to the existing product line. This is really important. Linear innovation is really important to sustain the existing business. So it's an important component of the innovation portfolio. Non-linear innovation, now you're starting to take a bigger risk. You're stepping outside the box that you've typically operated in. So your failure rate tends to be higher, but then if you succeed, if and when you succeed, the impact that you make is also significant. So nonlinear innovation is important to ensure that you are a market leader if that's what you choose to be. And lastly, disruptive innovation. This is, again, you're trying to, the only way that you can disruptively change your business is to try to put yourself out of business. That's when you come up with completely disruptive means to change the business scenario, right? One example, DuPont is a company that started out making explosives. They don't make explosives anymore. It's disruptive innovation within the company that led to that transformation. 3M, they make many products covering many different market spaces. They used to be a mining company, but they're no longer in mining. They were able to disruptively innovate out of that original market that created the company 3M. So I just want to give you a couple of examples of linear, nonlinear, and disruptive innovation. So if you think about shaving razors, so Gillette at some point went from a shaving razor having 2 blades to a shaving razor having 3 blades. If we step back and think about it, it's not that terribly innovative, but it was sufficient to keep Gillette relevant in the market. It was sufficient to ensure that Gillette continued to maintain market leadership. So that's linear innovation, right? It's a small step change to an existing product. When you think about nonlinear innovation, that's why the smartphone is one example that most people can relate to. You've taken a camera and you've taken a telephone and you put them together in one device. So now that's nonlinear innovation, right? So the companies that were making phones have entered a new market, which is cameras, or vice versa. The companies making cameras have now entered a new market, which is phones. Disruptive innovation, the iPod, right? iPod is no longer relevant today, but I think that's a really good example of disruptive innovation. The iPod created a need where a need did not exist. We didn't have people walking around saying, I wish I had 40,000 songs in my pocket. Nobody wanted that. But the iPod enabled people to have a library of songs at their fingertips. And so today, all of the smartphones have thousands of songs on them, right? That's disruptive. You created a need where one did not exist. So what does it take to be innovative? Try to spend a little bit of time here. So within a corporation, the first thing is a corporate culture. Now, when you think about corporate culture, the first thing that comes to mind, to my mind at least, is how entrepreneurial is this corporation? What is the risk-taking appetite of this corporation? What are the expectations of leadership? Do they encourage people to try and fail? or are team members within a corporation, are they afraid to fail? If you're afraid to fail, you're not going to be very innovative. So it all starts with culture, and it starts with leadership and what leadership expectations are. Once you have that in place, then you need to have a robust strategy. And we'll talk a little bit more about the elements that go into a strategy, a research and development strategy. And finally, once you have a strategy, you need to have the right competencies in place. And when we talk about competencies, it's the people, it's the infrastructure that you have to execute your innovation. So I think these are some critical elements to be an innovative company, right? It's the culture, it's the strategy, and it's finally the competencies that help you to enact or execute the strategy. I'm going to before we talk about culture, I am going to share a video with you. So Brad, let me know when you're able to see the video.
The shape of business is changing, which means your business needs to adapt. And that starts by...
So Brad, can you confirm that the YouTube screen is on?
The YouTube screen is not on. You might need to stop sharing your PowerPoint and share your web browser to get that started.
Got it.
The monkey business.
Are you able to see it now, Brad?
I can see that now, yes.
Perfect. So I'm going to share a video. It's about a minute long. And I'm not sure the audio from this particular YouTube video is going to come through, but that's okay. I will read. The audio is not critical for this particular video, okay? So you're going to watch a video, and the exercise here for all of you is to count how many times the players wearing white pass the ball. So you're going to be counting the number of passes made by those that are wearing white. Okay, so those of you that got 16 passes, great, but hold on.
Did you spot the gorilla? For people who haven't seen or heard about a video like this before, about half is the gorilla. If you knew about the gorilla, you probably saw it. But did you notice the curtain changing color for the player on the black team leaving the game? Let's rewind.
So you're going to watch the video again. And those of you that missed the gorilla, watched for the gorilla. And then, you know, some people are fully aware of the gorilla coming in between. But those of you that noticed the gorilla, think about the curtain changing color and also one of the team members leaving in between the game. Okay. So hopefully all of you got to watch the video, and Brad, if you can confirm that my PowerPoint is back on.
Your PowerPoint is on.
Perfect, perfect. And the idea behind that video was really to think about disruption. When, as corporations, we tend to be so focused on our immediate business or our immediate products that we forget to think about the disruptions that might be hitting us, right? And the gorilla video uh, was one way to show that disruption can occur or distractions can happen without your paying attention to it, right? So that was just an example, and hopefully you enjoyed that video. So again, coming back, right? If you are faced with a disruption, you need to have a prepared mind to take advantage of that disruption. And I'm going to share with you an example. Josh de Mestral was a guy that would take his dog on a walk every day. And he would take his dog on a walk through the woods. And every day when he came home, he saw these birds that would cling on to the fur of his dog. And he had the hardest time getting these birds off his dog. He was obviously frustrated, but he thought, what if I can use this concept to create a new product? And what if I can actually find applications for this new product? So that observation led to the invention of Velcro. We use Velcro in many of our devices today. We use Velcro in extreme sports. So the Velcro is now able to sustain significant weight, significant mass in dangerous situations. So again, I just wanted to use this as an example to highlight the importance of a prepared mind, and also to highlight the importance of having a corporate culture that promotes thinking, that promotes innovation, right? Where people are encouraged to bring new ideas and people are encouraged to fail as long as you learn from your failures. So the Velcro is one good example. Also want to mention another example. Hogan and Banks at Phillips Petroleum, many decades ago, they were trying to take the gases that come off a refinery and convert those gases into useful liquids that can be used as fuel again, right? So they were trying to basically reuse some waste products that come from the refinery. And in one of their experiments that went wrong, or when disasters happened to one of their experiments, instead of ending up with a liquid fuel, they ended up with a white solid substance. They chose to not ignore this as an accident. They had the curiosity to think about what this new product might be, what this white substance might be. That led to the invention of two of the most commonly used plastics in the world, polyethylene and polypropylene. Right? So again, it's the importance of a prepared mind and the importance of having a corporate culture that promotes curiosity-driven research. So I'm going to switch quickly and talk about strategy. What is a strategy, right? Strategy is nothing but a game plan, right? It's a game plan to help you differentiate yourself from your competitors. And a strategy has to have three important requirements, right? The first thing is alignment, right? The strategy that you come up with, or an R&D strategy, it needs to be in alignment with a business strategy. It needs to be in alignment with the capabilities that you have as an organization. And it also needs to be in alignment with the market conditions, right? So that's the first requirement of a strategy. Second one is coherence. And coherence means that the R&D strategy needs to be coherent with the rest of the organizations. What does that mean? Right? It's not enough to develop a research and development strategy if your manufacturing organization is going to act independent or outside of the core elements of this research strategy. So there needs to be coherence. So there needs to be, once you have a strategy that's in alignment with the business, you next need to look for coherence. So where really the actions that the different parts of the organization take are in coherence with the overall strategy. And lastly, consistency, right? The strategy needs to, you don't reinvent a strategy every month. When you develop a strategy, the strategy is typically good for a certain period of time, typically at least 2 to 3 years, depending on the industry that you're in. And so the actions that you take on a daily basis, they need to be consistent across that period of time. So those are the basic requirements of strategy. And then there are different elements of strategy, right? When you think about it, strategy, you start with, okay, do I have the right organization? Do I have the right org structure to execute the strategy? Do I have the right people? Do I have the right skills? And what does my research portfolio look like, right? There are some companies that may want to lean heavily towards linear innovation, and some others tend to lean heavily towards nonlinear and so forth, right? So you need to have all of these elements that go into the overall strategy. And again, there is not one magic formula for a research strategy that applies to all organizations, right? Each organization needs to develop a strategy that's core to their business, that's core to their markets, and core to their philosophy as a company, right? So a strategy is a very unique for each organization. I'm going to skip a couple of these and because we're running out of time, I want to now talk about different inspirations for innovation, right? So you have the conventional R&D where you get into the lab and try to make a better product. So the first topic I want to discuss here that's outside of the nominal convention has to do with innovation at intersections. And what does that mean, right? Here I'm talking about innovation that occurs when you bring people with different backgrounds and different disciplines and put them together, right? So typically, generally, when you get people with different backgrounds and different experiences, when you put them together and when you create a structure that's helpful, you get some pretty remarkable ideas. I'm going to share with you 2 examples. First is Diana Dabby. Diana was a very accomplished musician. She was living in New York City. She was playing in many of the city orchestras. She was a very accomplished musician. She would spend some time reading the recent research articles on music, and she started to see that some of these research articles had a lot of math in them. And so she was curious. And so she had somebody, she had a music background. Her education was in music and fine arts, and she was a professional musician. And now she was seeing a lot of math in the journals, in some of the new musical compositions. And so she discovered that the reason math was infiltrating into music was because you can take a musical composition and you can apply mathematical perturbations to that musical composition. So let's say you take a musical composition and you apply mathematical perturbation and you create 100 new musical compositions. Now, of the 100 new musical compositions that you create, 998 of them may be garbage. They don't sound like music. But out of this exercise, you've created 2 new pleasant musical compositions. So that's where math comes into play into music. So Diana was really curious about this. So she decided that she was going to quit her music career, and she enrolled in engineering, and she went on to get a PhD in electrical engineering at MIT because she saw a lot of potential to merge engineering, mathematics, computation with music. So Diana now teaches music and in specifically mathematical perturbations to music at the Olin College of Music. So that's a really good example where different disciplines come together to create something new. Another example is, this thing called biosteel. And I forget the name of the specific breed of spider, but there's this, I think it's called the golden orb spider or something like that. There's a specific breed of spider that the silk that it weaves, people discovered that this silk, this fiber, was about 7 to 10 times as strong as steel. So they call it biosteel. So when this discovery was made, scientists said, wow, now all we have to do is cultivate a spider farm. So we grow thousands and thousands of spiders, and then we extract the spider silk, and put them to good use, right? Because now this fiber is really, really strong. It's much stronger than steel. So it was a phenomenal business idea. It's a dream job, right? To work at a spider farm. It turned out that this particular species of spiders, they had cannibalistic tendencies. So they tended to eat each other. So when they created the spider farm, the spiders started to eat each other. And so the business idea flopped. So that's when the physical and material scientists got together with microbial engineers or biologists and then they isolated the gene sequence the gene sequence within the spider that's responsible for these really strong fibers, and they transplanted this gene sequence onto goats. Goats are very friendly animals. And so now what they did is they milked the goat and they convert the goat's milk into these fibers. So again, another commercial example of where different disciplines came together to create something that's new and that's unique. So the next concept I want to talk about is open innovation, right? When you think about innovation, there are two ways, right? You can carry out all of the research within a given corporation, and that's the traditional model. Or you can say, look, this is all that I can do. These are all the resources that I have to execute my research. So in order to augment the resources that I have, I'm going to reach out to the external world. I'm going to work with my customers. I'm going to work with my suppliers. I'm going to work with academic institutions. I'm going to work with national labs to augment what I can do internally. And that's really what open innovation is all about. And there are different forms of open innovation, from innovation challenges that are open to the public to very specific partnerships that you establish with a given entity. So in order to practice or in order to foster open innovation, you really need to have a culture that embraces the fact that you're going to be now using external input, a lot of external input into your research portfolio. And it also takes resources to manage this external network, because now you're working with people that don't have the same business objectives as you do. So you have to try to bring different business objectives together. So there are a lot of pros and cons, but open innovation is one good way to extend what you are capable of achieving or accomplishing internally. And obviously with open innovation, there are pros and there are cons, right? Advantages, you can go to market much faster, right? You can lower your total costs to develop new products. But then there are disadvantages, right? Intellectual property might get compromised. You're now sharing intellectual property between different parties. And sometimes you may not be fully in alignment with the business strategy, because now you're working with a company that has very different business objectives compared to you. So those are all things that you have to take into account before you embark on this open innovation space. The next concept I want to talk about is end user innovation. And let me share an example, and then we'll talk about specifically what end user innovation is. In the 1970s, windsurfing was starting to become popular, particularly in the coast of California. Then there was a group of people that really tried their very best to popularize the sport, windsurfing. And so it started to gain popularity. So there was a lot of work that went into designing these surfboards that people used to windsurf on the oceans. So there was a lot of emphasis paid to the design and the aerodynamics of these surfboards. But there was one challenge, right? So when these windsurfers, when they encountered a wave and they were thrown into the air, that was obviously really awesome from a spectator point of view. So now you had this windsurfer that was up in the air for several seconds before they landed back on the water. But more often than not, when they landed back on the water, the windsurfer or the athlete fell in the water while the surfboard stayed afloat. And so the people that made these surfboards were really focused in on the design of the surfboard to fix that problem. Because it would be really spectacular if the athlete remained on the surfboard when they landed back in the water. So Larry Stanley was a surfer, and he had a job where he would test the new products for these companies. And he was not happy with any of the products because they were no different. Every time he landed in the water, he splashed. He didn't land on the surfboard, but he was almost always in the water. So he just made a foot strap. So he just took a piece of nylon and made a foot strap on the surfboard. And that little innovation helped him to remain on the surfboard 99% of the time. And that innovation led to this sport really skyrocketing in terms of popularity. And also the companies that made these surfboards profited immensely. So this is an innovation that the end practicer of the product came up with. So this is the person that was using the product. This person was not satisfied with one element of that product, and he chose to make a change to that product. So this is what is referred to as end user innovation. Corporations, particularly large chemical companies, they tend to focus on products that meets a large segment of the market, right? Typically, big petrochemical companies are not interested in niche areas or in niche markets. But that's where these big companies tend to forget a segment of the market that could become significant. And so I think it's important for companies, when they develop a new product, they really need to think about how the consumer is using that product. And what is the consumer doing to that product? Is that consumer using that product as it was designed for? Or is that consumer making changes or making adjustments to the product to fit their own specific need or specific purpose? So if you pay attention to end user innovation, then I think if you can, perhaps you will come across ideas that you can incorporate back into your research and development stream. A really good reference material is this book called Democratizing Innovation by Eric von Hippel. Eric worked for many, at least I'd say many years with 3M. And they really revolutionized this concept of end user innovation. And this is a concept that's of interest to you. I would encourage you to refer to this book. I'm going to try to play another quick video that shows another example of end user innovation.
The support we've had over the last 2 months has been amazing. It's not just a work environment. Everyone here is family.
So Brad, can you confirm that the video is on now?
Yes, the video is playing.
Perfect. And unfortunately, you're not going to be able to hear the music or some of the commentary, but I'll try to fill in. So hopefully you enjoyed that video. So again, that was another example of end user innovation where the users improved on an existing product. So again, Brad, can you confirm that my PowerPoint slides are on?
We're in business with the PowerPoint slide.
Perfect. I want to finish here by talking about some of the disruptive trends that are upon us today, right? And I'm not listing all of them, but at least some of them, right? Artificial intelligence or machine learning. That's a new emerging trend. How can corporations think about incorporating concepts of AI into their business? Electrification of vehicles. It's not just the companies that make electric vehicles that need to contemplate this, right? It's the other industries that support the automobile industry. I mentioned gasoline, chemical industry depend on refineries to uh, for feedstock, right? We need raw materials to make products, and so we depend on refineries. If electrification of vehicles uh, becomes extensive, then refineries are going to go out of business, which means petrochemical companies don't have feedstocks. Autonomous driving is another one. E-commerce, and I think e-commerce is no longer a disruptive trend. It's already here to stay, right? It's already taken over our lives, particularly with all of the things that have happened this year in 2020. And lastly, climate change, right? Climate change and circular economy. So that's it I have, and hopefully I was able to share some interesting perspectives on innovation, and I will be happy to answer any questions from you either now or you have my email here. Feel free to reach out and ask questions via email. So Brad, I don't know if, let me see if I can actually look at the questions here. So do you want to handle the questions, Brad, or do you want me to?
I can handle those questions. And if you wanted to see them as well, I think you just need to end the PowerPoint presentation and you should be able to get that window on your screen. But I'll read off some of the questions that have already been typed into the Q&A box. And for those of you who didn't notice, down at the bottom of your Zoom screen, there should be a Q&A panel where you can enter in your questions for Raj. There's a lot to think about and a lot to talk about from tonight's presentation. So don't be shy. Ask as many questions as you like. They're all free. So I'll just start taking these in the order that they came in.
Okay.
So we have Workers First LLC. Says, what is the effect of designer polymers on polymer innovation? Do you think this type of innovation of switching out groups attached to different monomers is growing, or do you think people are still more focused on composites? I can read it again if you like.
No, I think I can see the question. I'm struggling with the definition of designer polymers, right? I think when you look at the chemical industry, by and large, the focus on trying to develop new polymers is not as high today as it was 15, 20 years ago, or even 25 years ago, right? So the type of innovation, switching out groups attached to different monomers, I don't see that area as an area of significant growth within the conventional chemicals industry. It's more of a specialty. But I still see that there is a lot of focus on composites, and there is a lot of focus on trying to adapt the base polymer with the reinforcement fibers in composites. So I see a lot of innovation there, not necessarily by introducing new comonomers, but using other chemistries to have the polymer, the matrix polymer, adhere to the reinforcement fibers a little bit better.
Okay. And so if that answers your question, great. If you have any follow-ups, feel free to put those follow-ups in the Q&A box. We've got two from Ruth Ann, and Ruth Ann provided the first question of the evening, which you addressed during your presentation. So this one appears to be a follow-up from the previous question. Please repeat when Braskem aims to be carbon neutral. And there's also a second one here. I'll give them both to you at the same time. Ruth Ann says, worked at 3M. Friday afternoon was only for working on something outside your assigned job to create innovative products. So maybe there's some you know, overlap between that comment and the question. Uh, Take it away.
Braskem has made a commitment to be carbon neutral by 2050. So that's 30 years from now. But we also have an interim target where we aim to reduce our carbon emissions relative to today by 15% over the next 10 years. So those are the two carbon commitments that Braskem has made globally. And we're going to go after this through multiple means, uh, from sourcing energy to alternate feedstocks. And we did talk about bio-based carbon used in polyethylene. We're looking to expand that space, create new materials using bio-based carbon, and also looking at avenues to create new products and new businesses using captured carbon, either from CO2 or methane. Can you take methane? Can you take CO2 that's emitted from our and other industries? Can you put them to good use and create new products? So those are all the different ways that we're looking at to try and achieve our carbon neutral targets. And I've read a lot about the 3M work culture, and I really appreciate this comment from Ruth Ann. Love it, love that 3M culture, right? And it's clear, right? When you look at the new products and when you look at revenues from new products at 3M, they certainly set a benchmark for the others to follow. And it's and I think that's where a corporate culture is really, really important.
Okay.
I'm really glad that comment came across.
Good. And if I could just follow up, we see some more questions coming up. That's great. So you said by 2050 to be carbon neutral. So that's a good 30 years off, and you got to assume there's a few generations of corporate leadership that will be shepherding toward that goal. So maybe you could just say something about how you think that process will work out through different leaders taking the company's reins every so often.
No, it's a really good question, Brad, and that's why it's important to have interim targets, right? So we have this mega goal of 2050, but we have set goals for 2030 as well, right? And the other commitment that we've made as a company, if you think about petrochemical companies, if we have to build a new plant, typically new plants or new manufacturing facilities cost billions of dollars, right? We just finished constructing a plant in Texas and a big petrochemical complex in Mexico. Both of those combined was $7 billion, right? So one of the other commitments that our senior leadership has made along with our board of directors is that the next mega investment will not be in a new greenfield plant to make more of the same. The next investment will be in circular economy, and or it will be to address some of these carbon concerns, climate change questions that are really critical and that are really relevant to our industry. So I think those commitments will certainly help us to achieve those goals, right? Interim targets, certainly a big part of that.
Okay. So the next one, my apologies if I mispronounce your name, Hunaid. What is the role of open innovation? Where do you see yourself in this open inside or outside innovation?
Good. So hi, Hunaid. Hope you're doing well. So open innovation is interesting. I think we need to think about both the outside in and the inside out models. And these models apply differently to different companies. It really comes down to the corporate culture and what your risk appetite is. Within Braskem, I can tell you that we've posed a lot of challenges to the outside world, right? So we're trying to crowdsource solutions. That's one model that we've been pretty comfortable in. So that's one model of open innovation that we've chosen. There are other ways where you can bring panels in and you can bring companies in and have them critique your business. We haven't done that as much within Braskem, but we've done that on a very selected basis, right? Where we have them critique a certain aspect of our business. But but we haven't done that as much. But posing problems to the outside world and trying to seek solutions. We've done that, mixed success. I wouldn't say that's been wildly successful. And I would say when you do that, the most important thing is defining the problem adequately, and so that the solutions that you get through the crowdsourcing is meeting what it is that you're looking for. So again, posing the question appropriately without giving away too much. I think that's a challenge.
Right, thank you, great question. We have one more submitted question from Hamina, and just a reminder that we'll take as many questions as come in, so don't be shy about typing those questions in the box down at the bottom of your Zoom screen. Really enjoyed your presentation. Braskem made national news with employees locked down in Philadelphia plant. Can you please share more information on this?
Really good question, Hamina. And I think what Hamina is referring to here is our plant at Marcus Hook, which is outside Philadelphia. When the pandemic hit, our product, particularly the product that's made in this particular plant in Philadelphia, is used to make the masks. It is used to make the disposable masks. It is used to make the N95 masks, the surgical masks. And so it was critical that this plant remained in operations. With the incidence rate of COVID going up, we did not want to risk shutting the plant down, because this was supplying to, this was actually filling a very critical need. And so it's the team members, they decided that they would live in the plant and they would not leave the plant. So we had a team that actually lived in the plant for 28 days, right? And they operated in 2 shifts. So they slept in the plant, they showered in the plant, they ate in the plant. And so they remained locked down within that complex. So to ensure that nobody got infected, and also to ensure that we continue to supply this critical material to the market. So that's what Hamina is referring to here.
Some real dedication. So I don't see any more questions popping up. Hey, just as I said that, Katie's question pops up. So feel free to type in as many questions as you like. Katie wants to know, what is one of your favorite products or materials that you have innovated?
So I have to refer to my time at Metabolics, where we were developing a family of polymers that were both bio-based and biodegradable. And one of the products that we developed was a family of products that were used, that could be used as agricultural mulch films. So if you think about agricultural mulch films, today polyethylene is used in these mulch film applications. So you put the film on the ground, and then you poke holes through the film, and you transplant the agricultural crop of interest in these holes. So around the plant, you have this typically black film that what it does is it minimizes weed growth, and it helps to increase the soil temperature during the early parts of the season, and it helps to minimize moisture loss. So these mulch films actually help increase the agricultural productivity. But there's a huge problem with these mulch films after you harvest the crops. You have to pull the film. And when you pull the film, you're dragging along a lot of dirt with the film. And then you have to dispose this film. So if you have 100 kgs of film on the ground, you're typically disposing 300 kgs because of all the trapped dirt. And there's disposal fees associated with that. So we developed a family of films that serve the same purpose, but after the crop is harvested, you can simply till the film into the soil and it biodegrades into the film. So I would say that is the product that I'm most proud of, although that never went commercial, because Metabolics as a company doesn't exist today. But there are other companies that are still working on those concepts.
Good to know. One more from Hunaid. What is Braskem doing to improve the recycling of multi-layered food packaging? So that's a real concern, and we see food packaging coming up in lots of conversations. So I'm Also, really interested to hear your answer on this one.
Yeah, this is a really interesting question, and it is a significant challenge. So let me first talk about one particular initiative that is public. We just received a US Department of Energy grant along with Case Western University and the Pacific Northwest Labs and also Procter & Gamble. In this particular effort, we're going to take the multi-layered films, put them through an extrusion operation, and use catalyst chemistry in the extrusion operations to try to depolymerize certain components of the multi-layered film. And so then what comes out of the extrusion operation is a more pure form of one polymer. So that's one initiative that we're looking at. Some other initiatives that not just us, but others in the industry are looking at. So when you think about recycling, you think about pyrolysis, chemical recycling or advanced recycling, you think about pyrolysis. That's a process that takes used plastics and converts it into feedstock, into monomer, naphtha-like oils that you can feed into a cracker and then produce virgin polymers again. But the pyrolysis process dislikes oxygen. And so we're looking at other possibilities to break down multi-layered plastics, like hydrothermal liquefaction, right? Where we use supercritical fluids to break down. So now when you use supercritical water, you're no longer sensitive to oxygen-containing polymers that are very prevalent in these multi-layered films. So that is another initiative. But then we're looking at others as well, but those are two that I can share.
Okay, thank you.
But that is a big challenge, right? That is a significant challenge.
All right, and we've got breaking news here, Raj. Who we thought was Ruth Ann that we were talking to is actually Charlie. Ruth Ann is Charlie's wife, and so it's Ruth Ann's name on the Zoom, so we'll clear that up right now. Thanks for a most interesting presentation. Are your slides available publicly? And Charlie's been retired 20 years from providing support for injection molders of engineering plastics, particularly liquid crystal polymers. So before you answer, whether the slides will be available, I will say that this presentation will be archived on Carnegie Science Center's YouTube channel. So that will be live in a few days. So whether or not you are making your slides, publicly available in the PowerPoint file, look for us on YouTube. But I'll pass that back over to you, Raj.
I will be more than happy to share slides. There's nothing proprietary in the slides. Be more than happy. Brad, you're welcome to share with audience members, or if they can email me, I'll be more than happy to share them as well. And I'd love to see somebody that had worked on liquid crystal polymers before, because my postdoctoral research was on liquid crystal polymers. So it's neat.
Very neat. A small world.
Small world, yes.
Okay. So yes. So whenever you are going back to check out that YouTube link, feel free to share that with your friends. Email it to your weird uncle that nobody likes to talk to at holidays. Share it widely. I think that there's something for everyone to enjoy in all of our Café Sci presentations. We'll give just another moment for any questions that might trickle in for the end here. While we wait for any last minute questions, I will invite everyone to join us for our next presentation in Café Sci. That will be on Monday, January 3rd. And our speaker will be Devina Durgana from American University. And her talk will be, I'm going to scroll for that title here, Finding Today's Slaves, Statistics in the Fight Against Modern Slavery. So all about statistics and math and human rights. So tune in next month. Remember, you need to register in advance to get that Zoom link. No other questions seem to be rolling in. Raj, I want to thank you so much for spending an evening with us and our audience and sharing your experiences and insight. And if there's any parting remarks you'd like to make, the floor is yours.
Thank you again, Brad, for this opportunity. I really particularly enjoyed the questions from the audience. And too bad we couldn't do it face to face because those interactions are really special. But still enjoyed it. I'm going to be giving a version of this. I know next month at Case Western, so it helped me prepare for that audience. And again, love the Carnegie Science Center, love all of the Carnegie museums, and I really applaud all of you, Brad, and others that are part of the Carnegie Science Museum and the Carnegie the Arts and Natural History Museums. They're all beautiful places. You provide a great service to the local communities. We've always enjoyed visiting these museums. So again, thank you. I think you're doing a great service to the community.
And thank you for those kind words and for being with us. And thank you all for tuning in. Until next time, wash your hands and be kind to each other. We'll see you all in a month. Thanks again.
Thanks, Brad. Take care.
Bye.